Welcome you all in this lecture. We are going to discuss a very interesting uh, uh, case in computation of effective stress. A very interesting case. What is the influence of rise of water level above the ground surface on effective stress? This is a very interesting case. What happened? You see, many times you see, we used to see here this is the ground level. So this is the level of the ground, and sometimes you see this ground itself is drowned. That means, see, we as of now we discussed water table. There is no water table within the ground under consideration, or we are trying to say water table is at ground level. But this time, water table is above ground surface. This, in fact, I am not interested to call water table. This is water level. So here you see this is a water body. Uh, we have considered lake here. Lake is the water body, or it may be a pond or any water body. Here you see what I'm trying to tell you. What is the influence of water level? What is the influence of water level on effective stress at any point P below the ground level? At any point P below the ground. I have a ground here, you see. I have considered one mathematical numerical example. I have a soft clay here. So above soft clay, we have a lake water body. The height of the water body is h. Let me assume lake has one portion. The second one is soil here. We have two items, two entities. One is lake, the second one is soil. Here you see water level is above the ground surface. So what is effective stress? That is very interesting. So how to compute effective stress when when water level rises above the ground surface? Just like you see the lake, this is the height of the water in the lake. So that is I want to call a small h. The thickness of the soil is h. Now you see I'm going to calculate total stress. As you know, if I want to calculate effective stress, how to calculate total stress, then pore water pressure. Ultimately, it is easy to compute effective stress once you know total stress and pore water pressure. Sigma dash is equal to sigma minus u. Now let us proceed now how to calculate sigma. Here you see we have water. This is water. The unit weight of water is gamma W. So now you see 0. When it comes to bottom of the lake, we are having a pressure, water pressure, gamma of water into height, gamma W into height of the water is small h. So now it is going to be constant. Now it is acting as a overburden on the soil. Now it is going to be constant. In fact, it is a surcharge. Now I can use this. Now this is acting as a surcharge. Now you see gamma W into small h, height of the lake. Now one can see here gamma W into small h. Now let us proceed now. Regarding soil, we all know how to calculate because this is saturated soil. So how to calculate gamma sat for saturated soil? We know by degree of saturation, taking degree of saturation 1. So one can easily calculate. If you don't know E is equal to WGS by SR. Here SR is equal to 1. So now one can calculate gamma sat. Here I got gamma sat 17.66. This is regarding clay. Where gamma sat is not given, he is given W1GS, but we are not worrying about it. We can calculate by knowing the fundamental relation. Now I know gamma sat. Here the thickness of the soft clay is given 15. So gamma sat clay into 15. I can calculate now sigma. Now coming to pore water pressure. Now this is very important discussion. Pore water pressure, small u. Right now we calculated sigma right from top of the lake to bottom of the soil under consideration. That means here we are trying to call point P. Now you see regarding pore water pressure, here you see we have water here. So we should not neglect gamma of water. That is the unit weight of the water in the lake into height of the lake. So h, now it is going to be constant. So gamma W into h. So it is also there in pore water pressure now. Small h, I can tell you height of the lake. Now as usual, so for soil, we have a water table here, you see. In fact, water table not only at ground surface, water level above the ground surface. That is a very interesting thing. So now you see, I can calculate now gamma W into thickness of the soil is capital H here. Now, how to calculate sigma dash? Here you see, I have 0, 0 minus 0 is 0. Now, how to calculate effective stress at the bottom of the lake? Here you see, I have total stress gamma WH and I have pore water pressure gamma W into H. So, H means here small h, height of the lake. So, if you see here, if you observe clearly, so water body imposes equal increase in total stress and pore water pressure gamma W into small h, gamma W into small h. So I want to note it. So here you see presence of water body will increase total stress and as well as pore water pressure. In fact, equal increase. I would like to mention equal increase in both total stress, equal increase in both total stress and pore water pressure. It is gamma of water into small h, gamma of water into small h. So where h is the height of the water body, here the water body is lake. So that's why what happened now in effective stress there is no change. Therefore, because of equal increase in total stress and pore water pressure, there is no change in effective stress. Zero. So there is no change. I would like to write here no change in effective stress due to due to water body. Here is a 0 gamma w into small h minus gamma w into small h, which is going to be 0. Now let us come to soil portion now. So as usual, we know gamma dash h. In fact, gamma w into small h minus gamma w into small h has been cancelled. Here also it is cancelled. Finally, we can see here only gamma prime soil into gamma prime soil into H. Here we have 15 gamma prime. You can able to calculate gamma sat minus gamma W. We got gamma sat of the soil 17.66 minus 9.81. That gives the answer. Here you see 117.75. So this is about influence of rise of water level above the ground surface on effective stress. Rise of water level. So finally, what I am trying to note, there is no change in effective stress. The important note is no change in effective stress due to no change in effective stress due to no change in effective stress due to rise of water level above the ground surface. This is very important point. Please, all of you, practice more and try to understand this. Thank you all.